Greetings, mathematicians. Welcome to this narrated PowerPoint on trigonometry, special angles. So, even though your calculator can pretty much work out all the trig ratios in the world, thank you, Mr. Sharp, thank you, Mrs. Cassio, we are forever in your debt, there are some angles for which we are required to memorize the values of their trig ratios. These are called special angles. Now, what are these special angles to which I refer? It is these angles: 0 degrees, 30 degrees, 45 degrees, 60 degrees, and 90 degrees. We are going to have to know the sine, the cos, and the tan for all of them. And when I say know, I mean know them off by heart. But thankfully, it's not that hard. You'll see why. So this is what they are. The sine of 0 is 0. The sine of 30 is a half. The sine of 45, it can be either written as root 2 over 2, or it can be written as 1 over root 2. If you want to try those two out on your calculator, you'll see that they're actually exactly the same. The sine of 60 is root 3 over 2. The sine of 90 is 1. Then if we go to cos, the cos of 0 is 1. The cos of 30 is root 3 over 2. The cos of 45 is root 2 over 2 or 1 over root 2. The cos of 60 is a half, and the cos of 90 is 0. Now, the more astute observers amongst you may have noticed something about the sine and the cos special angles. They look very similar, but maybe one of them is backwards. And then we move on to tan. The tan of 0 is 0. The tan of 30 degrees is 1 over root 3. The tan of 45 is 1. The tan of 60 is root 3. And the tan of 90 is undefined. Now, when it comes to the sine and the cos, there is a fairly easy way to remember their values, and it looks like this. If we go and look at the sine of 0 degrees is root 0 over 2. And root 0 over 2 is, of course, 0. The sine of 30 is root 1 over 2. And of course the root of 1 is 1, so that's a half. The sine of 45 is root 2 over 2. There it is. The sine of 60 is root 3 over 2. There it is. And the sine of 90 is root 4 over 2. Of course, root 4 is 2, and 2 divided by 2 is 1. You will notice at the top here it goes 0, 1, 2, 3, 4. And the denominators are all 2. Then if you look at the causes, it's exactly the same pattern, but backwards. It goes root 4, root 3, root 2, root 1, 0. So that I find to be a fairly simple way of remembering the sine and cos special angles. As far as the tans go, you'll just pretty much have to remember them, but thankfully they're not that hard to commit to memory. So, we are not only required to know the special angles, we are sometimes required to prove them. In other words, how do we know that those special angles actually are what they are? So let's start with the 45 degree special angle, shall we? What kind of right angled triangle has a 45 degree angle in it? Well, there can be only one. It would have to be a right angled isosceles triangle. That's the only kind of right-angled triangle that would have a 45 degrees in it. So there's a right-angled isosceles triangle. These two angles here are 45 degrees. Now I'm going to make the length of this side 1 unit long, because 1 is an easy number to work with. So we just need to quickly use Pythagoras to work out if this is 1 and that's 1, how long will the hypotenuse be? So we do some Pythagoras upon our calculator, and we figure out that the length of the hypotenuse will be root 2. If you don't believe me, do it yourself on your calculator. Now, let's work out our trig ratios from this triangle. If I want to work out the sine of 45, sine is opposite over hypotenuse. So it's 1 over root 2. There we go. Cos is adjacent over hypotenuse. So it's also going to be 1 over root 2. Tan, the tan of 45, is opposite over adjacent. So it's going to be 1 over 1, which is 1. So that's the 45 degree special angles proved. Now let's move on to the 30 and the 60 degree special angles. Well, how can we get a right angled triangle that has a 30 degree and a 60 degree in it. This is how. We take an equilateral triangle and cut it in half. So here's our equilateral triangle. If I cut it in half, such that this is a right angle here, that angle is going to be 60 degrees because, of course, all the angles of an equilateral triangle are 60 degrees. This angle here is going to be half of 60 degrees, which is 30 degrees. So now I have a right angle triangle with a 60 degree angle in it and a 30 degree angle in it. Let's make this side here 2 units long, so that when I halve this side here, I get 1 unit, because 1 is an easy unit to work with. Then I just need to do some Pythagoras to work out how long this third side of our right angle triangle is. I'm completely ignoring the right hand half, by the way. I'm just looking at the left hand half, this right angle triangle here. How long will this side be? Well, we do some Pythagoras and we figure out that it'll be the square root of 3. Try it on your calculator if you don't believe me. Hey computer, what are you doing? Stop doing things by yourself. I did not press the button. I did not. Gosh. Go back. No. Other way. What? Stop. No. Obey me. Gosh. It's AI taking over the world. Where was I? Okay. Yes, I was here. We have our triangle. Let's look at our trig ratios. Let's start with the 60 degrees. Sine of 60 is going to be opposite over hypotenuse. So it's going to be root 3 over 2. Cos of 60 is going to be adjacent over hypotenuse. So it's going to be 1 over 2. Tan of 60 is going to be opposite over adjacent. So it's going to be root 3 over 1, aka root 3. Now let's look at the 30 degrees. The sine of 30 degrees is going to be opposite over hypotenuse, so it's going to be 1 over 2. The cos of 30 degrees is going to be adjacent over hypotenuse, so it's going to be root 3 over 2. And the tan of 30 degrees is going to be opposite over adjacent, so that's 1 over root 3. And that, ladies and gentlemen, is how you prove the special angles for 30 degrees, 45 degrees, and 60 degrees. Now let's look at some worked examples of where you might encounter such special angles in the wild. You might see a question that looks like this. Determine the value of the following without using a calculator. And that, ladies and gentlemen, is the key. This phrase here, without using a calculator. That is the phrase that tells us that special angles are probably on the way. So we look at that. 30 is one of the special angles, 45 degrees is one of the special angles, and this 30 is also one of the special angles. So all of these are special angles. So in order to solve this, what we need to do is think through our memory bank. Sine of 30, what is that? Search memory files, and we find that the sine of 30 is a half, the tan of 45 is 1, and the cos of 30 is root 3 over 2. Now what we've got here is cos squared 30, which means we've got to take the cos of 30 and square the whole thing. So what's going to happen if I square this whole thing? Well, if I'm squaring a fraction, I need to square the top and square the bottom. Root 3 squared is 3. 2 squared will be 4. So I'm going to end up with that. And now it's just a case of adding fractions. A half plus 1 plus 3/4 is 2 1/4. Look at that. How wonderful. Question B. Sine of 45 times cos of 45 divided by the tan of 30. So, special angle, special angle, special angle. So we search through our memory bank. We ask the little secretary in our brains to go through the filing cabinet where we've stored all of these special angles in our memories. And we figure out that sine of 45 is 1 over root 2. Cos of 45 is also 1 over root 2. Tan of 30 is 1 over root 3. If I multiply these two fractions in the numerator together, 1 times 1 is 1. Root 2 times root 2 is 2. So I end up with that. Now I've got a half divided by a fraction. How do you divide by a fraction? Well, you do the old tip and times. There it is. and top times top, bottom times bottom, and we get root 3 over 2. It's true. Finally, question C. Here it is, cosec 60 times cot of 30. Well, 60 is a special angle, 30 is a special angle, and cosec and cot, those are reciprocals. So dealing with reciprocals, don't get yourself into too much of a panic. You think cosec is the reciprocal of what? It is the reciprocal of sine. So I'm going to take the sine of 60, which I have in my memory as root 3 over 2, and just turn it upside down. Cot is the reciprocal of what? It's the reciprocal of tan. So the tan of 30 is root 1 over 3. What am I talking about? 1 over root 3. So I'm going to take that fraction and just turn it upside down. There we go. So this is the sine of 60 upside down. This is the tan of 30 upside down. That's how you deal with reciprocals, ladies and gentlemen. Just turn them upside down. And now I can do some cross-cancelling. The root 3 and the root 3 are going to cancel out. Goodbye to you, root 3s. And we'll be left with 2 over 1, which is also known as 2. Well, ladies and gentlemen, boys and girls, it's been emotional. Okay, bye-bye.